Yeah, Rahul, you had a question? Just type your question in the chat, right? And I'm not able to see Dr. Rakesh on the participant list. Just 1 minute. We just want to do a sound check because he's the dean. We just probably need to coordinate around certain slides he also will talk to you about. Dr. Rakesh, I don't see you in the participants list. Just take a look at the message Shonali is giving you guys. I think she's just wishing you all are safe and taking care of yourselves. Just trying to locate Dr. Rakesh's profile because I have to unmute him. Okay, we'll just get started in 1 minute. Just waiting. Excuse me. I believe there are quite a few participants. So I'll just rely on Shonali to let me know when everyone is logged on so that we can get started. There's a lot of content to cover, though I'll try and kind of keep the pace slightly slow so that those who are not very familiar with some of the aspects of data science can also follow along, right? Okay, Shonali, can I start? Because I think most of the people should be on the bridge. The challenge I see is I'm not able to see Dr. Rakesh on the participant list. So I'm not able to check whether his sound is working. Okay, just for the sake of time, let's get started. You see the slides in front of you. Just let me know if any of you are not able to see the slides. Just type yes or no on the chat window. Okay, so I presume most of the people are able to see. So let me just get started, okay? Because there's quite a few things to cover, and we will also talk about the program in detail, right? So the topic is, to try and understand how data science fits in business, and it's, one of the most important skills professionals need to have in these times. Right? So what we'll try and do is cover something on what is data science, talk about what are the skill sets people need to pick up, and what really does a career in data science entail in terms of when you have relatively fewer years and when you become a more experienced manager. And then we will talk about the InSophie program, which is in partnership with IFM, right? So let's just get started. So if you can see these slides, I think all of us have seen what this slide really indicates, right? That data is absolutely ballooning up in terms of volumes. When you look at, the 1990s, and I think most of you were born at that time, that was where you had companies like SAP, Oracle, who were the people who had data warehouses and, databases, and had created this whole business around enterprise systems. And there, when we were talking of scales of data, we were talking of terabytes. Terabyte is typically 1,000 gigabytes. So it's something like 10 raised to the power 12 bytes, right? So if you look at how data scales have been increasing, the next stage was all the, specific enterprise software like Microsoft Office 365, which most of you must be using, Adobe, and so on. And these people sort of not only had data to store, but they had images, even video, and so on. And therefore the scales of and size of data moved into petabytes. So petabyte is typically 10 raised to 15. Just for information, if any of you are following what's happening with the CERN, Large Hadron Collider, which was trying to, understand, the boson, which was predicted by Einstein and had not been found till now. The kind of data that is computed by the Large Hadron Collider is only in the scale of 15 petabytes a year. So that should give you an idea of how large is a petabyte. It's 10 raised to 15 bytes, right? And then when you look at newer technologies like the cloud-based systems where you have NoSQL databases, you have a lot of video on demand, you have a lot of genetics, sequencing, gene sequencing, and Twitter, and all kinds of types of data. We are now moving into the exabyte scale, right? So exabytes is again, 10 raised to 3 higher than petabytes. So what you see in terms of the graph is really a logarithmic scale where SAP Oracle is, let's say, 1 on the scale or close to 0. And then petabyte is 3 on that scale, and exabyte is 6 on the scale, right? So these are all, like we said, logarithmic 10 base scale, which is trying to compute, that the data is multiplying by 1,000 or a million, and that's what this chart indicates. Last year, there were close to 300 billion emails, 25 billion WhatsApp messages, 5 billion videos, and so on, which was being pushed onto the web every day. And even then, if you take the entire volume of data that was generated in a year, it was 5 zettabytes. Okay, a zettabyte again is 10 raised to 21 or 1,000 exabytes. And that is going to scale up over the next 6 years to 175 zettabytes. So you can just imagine how things are changing, right? And this is some of the forecasts that we have from IDC and Forbes. So soon we will actually forget everything about gigabytes and petabytes, and we will talk only in terms of zettabytes, and going forward, yottobytes and brontobytes, right? So these are all GK questions, where what we are looking at is just moving up by a scale of 1,000 every few years. And that's the new reality. So if we have to manage these scales of data, guess what will be the most important function, right? I mean, it's a no-brainer. I mean, it's all about people who know how to manage large scales of data, whether you call it big data or data science or data analytics. Pretty much means the same thing, is someone who's familiar with the use of uh, data at scale, being able to throw up insights, right? So everything from data is not just about managing data, but what is the kind of inputs or insights it gives. So I think I took the thunder away from this slide, but what essentially this slide was saying is essentially the same thing, which is really data science is all about turning data into actionable insights. I mean, what insights can be actioned. Um, it needs to understand the type of data. So, someone who's actually trying to manipulate data is not someone who just knows few lines of code, who knows how to extract data, what is called data frames, pull in data, and everything else gets done by the computer, right? This should be also a skill where you are able to understand what is the uh, granularity of data, what is the kind of data where which are the important features which will determine what you're trying to predict, and how clean or noisy is that data, right? So someone who's coming from data science has to be able to assess the quality of data, and that is what we mean by data pattern. Someone who has a feel of the data, he should be able to formulate an hypothesis. So this is what statistics teaches you, all about hypothesis testing. So data science is really a mix of statistics and big data. And then you basically need to get the insight to whether, I'm sorry, the analysis to determine whether you reject or accept the null hypothesis, which is what you learn in statistics. And then finally from there, what is the insight? So really the product of data science is the insight, which is all around what is the data telling us, or what is the data hiding because we don't have good data. What is the sort of action we can take which will reverse an adverse trend, or supplement something which is going well, right? So these are all things that basically business managers need. So this is really a science which is feeding into business. This is not a science which is feeding into geeky research, which is lying in one corner of the organization, and people don't even know what kind of work is being done here, right? So that's the difference. This is really feeding right into the core decision maker or the business manager, and really what the models and the data throw up are insights. And what that throws up is, if you are able to manipulate the data in terms of mix and match, what kind of features you need to pull out to be able to throw out even more deeper insights. That is what a data scientist does. So this loop of 5 or 6 bullet points is really the role, at a very high level of a data scientist. And obviously, knowledge of statistics is important, but what is even more important is the understanding of the domain, the industry, that where you're trying to solve the problem. So someone who's coming at it purely from a mathematical side will clearly not be very effective. Now, the other question that gets asked is that, is it a new science? And clearly, this is not new. I mean, I'm sure when we look 2,000 years in the past, whether it's the Greeks or, even the early Indians, and, the contribution Indians had to the field of mathematics. So all these techniques of managing, large amounts of data was being attempted without a computer, right? Right. I mean, in those times you didn't, but people were trying to still solve problems. So I would say this area of knowledge is not new at all, but it is really the ability to collect real-time data from sources even outside the organization, which is what makes the analysis richer, as well as very high computational power, which is running into very high compute capacity, which you can take off the cloud, You don't necessarily need to have those machines in your data center or in-house, and also ability to store the data, right? So one very important skill is, what window of data is really relevant. I mean, you can go on collecting data for 20 years, but if that is not related to, if you have a rule where the most recent data is the most relevant, then why would you store 20 years of data, except maybe for regulatory reasons. So understanding the right amount of data to store for solving the problem the way you want, all this is what culminates into this very interesting area called data science. There are three pillars. So the first area is really the business context. I would say this is the most important pillar, and that's why it makes so much more sense as part of a business management course, right? Because you're learning business management and the core business courses on one side. You're also learning deep data science through, the specific program we're going to talk about, where you learn about statistical models and machine learning algorithms. I'll cover that in a minute. And you're also understanding how to manipulate data. So this is all around, like I said, ingestion of data, what is called ETL, extract, transform, load. These are all around managing the technologies. And this is something that, is expected to for someone to be able to be experts in at least two out of the three areas, if not all three, where you're able to manage all this on your own without needing help of IT or a DBA, a database administrator, right? I mean, earlier, business folks would just go to a IT person or a DBA and say, okay, do your SQL queries and get me this data. And that created a challenge in itself, because obviously there was a priority of needs, and if you were low down in the organization, your needs would get catered to last. And what that meant was that your problem would take 1 week to solve, because you're waiting for this person to come back with whatever information you required. Here, the entire liberating thought around data science is you can do it all yourself, and these are technologies that can be easily learned with the right amount of diligence and interest, so that you can actually, one, define the problem from a business context, use the right statistical methods and machine learning models, and then use the right tools. So whether it is from um, uh, like we said, a data frame network to be able to pull in data, to be able to use the right code for the model, or the right model, which you're again getting from the machine learning algorithm, and then being able to extract and visualize it, so that it is something which can be interpreted by management, right? So those are the three real pillars of data science, and which you will learn as you become an expert in this area. Okay, let me just go and see if there's any questions. What about problems are known to take up huge amounts of time to solve, like in the NP complete complexity set? How do we implement data science methods to make progress in that area of computation? So good, at least one person has familiarity with optimization, right? So Siddharth, I think the issue is that if you look at conventional linear programming and solvers, right, a lot of the problems were defined as NP complete, because there was no real optimization possible, because there were so many variables. Because of the options available, you could run into millions of options, and then you would try and curtail that solution space so that you could get a feasible solution. But the issue, I think, is really that what knowledge of data science also gives you is how to bypass a NP complete problem. So for instance, there's something called approximate algorithms, right? So these are things which are not coming through as a optimization output. So all people on the call, I know you may not be following everything, but just, I think since this question was asked, I thought I would just mention that these are all things that will be taught, that if you are in a realm of linear programming optimization, you have NP complete problems which you can't solve. How do you get the right toolkit to be able to solve such kind of problems, right? So then you go into approximation algorithms. So for instance, if you know bin packing, knapsack packing, these are all problems which get done through what is called first fit decreasing, next fit decreasing, and so on. So there is a lot of techniques that come about to be able to bypass this. And that is what science is teaching you, that okay, it's not just about trying to be a mathematician, right? It is, and reading the latest research papers and trying to implement that, or trying to find out whether a optimized algorithm works or not. Your point is business leader needs a solution in 3 days. How do I provide that solution in 3 days being a one-man army? I'm not relying on the IT guy or the database administrator to give me data. I'm not relying on a conventional technique which I know goes into it's being NP hard or NP complete kind of problem, which will not get solved in finite time. So how do I actually get a feasible solution? Then how do I iterate from that solution to something which is more optimal? How do I get to a local minima from that initial starting point, which is a feasible solution? So all these are what you get taught in this course. And the other thing is that there is no need for having a science background or a math background, right? I mean, these are things which is really where your interest and ability to partner with complementary skill sets. So if you are a, let's say, person who's understands an industry because you've had work experience in a particular industry, or a particular industry very well, you can partner with the computer science guy, and who, let's say, comes from who's a fresher from computer science, to be able to kind of work in teams where you can solve this problem working on your strengths. And that's really what MBA curriculum teaches you. And at the end, both of you know the problem with equal depth. So I would say that please try and look at things from how this solves a business problem. Okay, I think our dean, Dr. Rakesh, is also joined, so I'm just unmuting him. Dr. Rakesh, are you on?
Good afternoon, everybody. I hope I am audible, Dr. Soumya.
Yeah.
Okay, so my apologies for coming in late, because I was really struggling with the system and power issues at my place. But I will, join you now, Professor. You can continue, and maybe I would give an introduction once my, the business part of the program comes in. So I would welcome everyone who are there today with us in this webinar. Thanks for joining us.
Thanks, Dr. Rakesh. I'll just mute you again, just in case there's any static. Okay, so moving forward, I know we didn't introduce ourselves, so we'll probably do that next, because I think I just got started. So the 4 bins of analytics problems, like we come from the previous context, and just don't worry if you don't understand any specific thing. The issue was I was just trying to address Siddharth's specific question. Okay, so prediction is around really trying to forecast a particular dependent variable. It could be sales, profits, whatever, where you have host of past data. So you could use things like we have conventionally used, like time series, exponential smoothing and all that. But we could also use predictive machine learning models. So what this is trying to predict is that I have a set of data. How do I predict what will be that parameter, whether it's sales or profits, going forward? Because this is what I need to ensure that I'm on my target or I'm exceeding my target, right? So I need to get forewarning so that I'm pushing forward with with the right amount of effort. Customer lifetime value, again, is a prediction problem where I'm trying to understand what is the total value that a customer will give me over his lifetime. And then there's all kinds of techniques like cross-sell, upsell, which gets done by people once they are able to understand the likes of the customer, what he really desires and what he's willing to spend money on. Then you have this classification problem, and these 2 categories of prediction and classification really comes under what is called supervised training or supervised learning. And here you're trying to assess, the risks. So, which customer can churn, which customer can default, which customer can I give a loan to because, he's creditworthy, right? And the whole issue is that did these things not exist? Of course it did. I mean, you had underwriters who would come back after 3-4 days and give you a view, or maybe 7 days if you are taking a home loan, because there's a legal person involved, there are various people involved who all need to feed that inputs. What here we are talking about is real-time credit risk check, right? So if I'm giving a personal loan to someone, can I do a check card loans and how he's generally paid, let's say even his society loans, if I have a access to his bank account, to see how regularly he's making payments. So it's not just ability to pay, it's willingness to pay as well. So these are all I'm trying to assess in real time, to assess whether I should give this person a personal loan which is unsecured, as right? I mean, there's nothing I can do to get it back except the ability of the person to pay back, and it's I'm sorry, even his willingness, and also how secure he is in his job. So is he someone who will continue to earn a salary, or he's someone who will probably be out of a job and then he will have no way to repay, right? So those are all decisions that are getting made in real time. So can you imagine how many pools of data are coming in to be analyzed, so that someone who's a bank officer or someone who's trying to sell these products are able to make the right decisions. And then you have things like matching. So, the fingerprint matching, which we all know for our mobile phones. And obviously, there are different techniques around image and even, capacitive, fingerprint matching, which today all systems follow. So they don't check the image of your finger, but it's the distance in the grooves of your finger, which is, has a capacitance. And that capacitance is measured, and, it's very unique to people. And that's what the phone is actually, as a computer itself, matching and enabling you access. And then you have recommender systems, if Flipkart, Amazon, which says that, okay, people like you also bought this, so they are making recommendations based on classifying you as a particular type of person, say someone who likes A or B kind of products, and therefore you should be tempted enough to buy this, right? And then you have optimization, the question Siddharth asked, that how do you solve NP complete problems? And these are really around traveling salesman problem, which is vehicle routing, bin packing, knapsack packing, all these problems, right? So they were earlier solved by linear programming and solvers like Cplex, Gurobi, and all that. Today, you have machine learning models which solve this with equal ease. You also have, something called reinforcement learning, which is the cutting edge of machine learning, deep learning, which is now also being used as a tool and technique for data science. Okay, this is something that is important to understand what is different between business intelligence and data science, right? So the conventional business intelligence, what you have in Cognos and some of the dashboard tools, sorry, which IBM, SAP, Oracle all have, which are throwing up business intelligence sort of inputs from your enterprise data. How is that different from data science? So essentially, the issue that business intelligence is solving is it's trying to visualize data like your past quarter sales, whatever is there in your existing ERP, as to what happened in terms of the last few quarters, what is the actual volume sold, and so on and so forth. What were bottlenecks for why things didn't sell, which were internally controllable, right? So these are all trying to leverage structured data, which is stored in your own databases, and come up with ways in which it does standard reporting. That means what you get every day or every week, and ad hoc reporting. So if a business user needs to get certain data, again, he will have to get in touch with the IT guy and say, okay, can you do a SQL query? And then the IT guy will run an ad hoc report for him, right? So this was how things used to work in the past. Now, what is data science is trying to tackle is the question Siddharth had. It's around optimization. It's around predictive modeling. It's around trying to find out what is the right way to operate so that you are operating at your best. What that means is that, apart from the factors which are controllable by you, so if you had some shutdown in your plant, or you had certain supplies that dried up because your supplier did not supply, or some machines broke down and it should have been maintained well, all these things over and above that, you need to predict if a machine is going to go down, for instance, right? Because it's been operating at 24/7. There's been less of maintenance. So, can you get the tool to predict which machine is going to go down, so that you can take care of getting another machine installed in parallel, so that you don't lose out on production? Similarly, can you use external data, like let's say rainfall, or weather data, assuming your product is linked to that, with a strong correlation, to really understand, what would be the real demand going forward. So if you sell ice cream, and the summer is actually still chilly, and the winter hasn't given way to summer kind of climate, people are still not going to buy ice cream, even though technically you are in summer, right? So these are kind of things which every business person wants information on. So these are around what ifs. These are around scenarios. So if this were to happen, what would I do? So they have a set of rules that they can follow very easily, and more importantly, it's all proactive. So they know 1 month before that this is a likely scenario, or this is likely to happen. How do I take care, right? So that is, I think, again, what data science gives you, the ability to predict the immediate future, so that there is something called predicative or prescriptive analytics. So these are not predictive. Predictive is just what the data is throwing up, better estimate. This is what could potentially happen. And what I think research is trying to do is even try and predict black swan events like COVID, right? I mean, like the 2008, I don't know how many of you probably remembered the banking collapse, Lehman Brothers and others, through all these asset-backed securities, and the bubble that got built up over 2-3 years. Same thing happened to the dot-com in 2000 and 2001. So who can predict these kind of cycles which lead to a black swan event, which kind of causes a global recession, right? Or it kills a particular industry, and so on. So these are things which also people are trying to predict using data science. So if we really look at the what really people need to do here, and I will go a bit fast here because I know we're running a bit short on time, is you have to really understand that the problem definition is the most important, and that's where understanding the business is so important, right? That's why they say you're a sector specialist. If you go to a consulting firm, they'll call you a sector specialist. Why are they calling you that? They could say you are a machine learning specialist, but no one calls you a machine learning specialist. They say you're an auto specialist, or you are retail specialist, because you know everything related to that sector, or at least broadly how it works. And so again, this is the top down skill that is so desirable today. Then you kind of go about trying to understand what are the relevant features, or what are the relevant independent variables on which your problem variable that you're trying to kind of predict or assess is going to be dependent on. So then you kind of go and extract that relevant data, because again, if you remember, you have a feel of the data. If you are mechanically just going and loading CSV files or Excel files, you are not a data scientist. You are someone who just knows how to manipulate data files, right? So that's again where from that feel of the data, what is relevant, what is not relevant. And you can also go and ensure certain fields which will cause an error is deleted, or is not considered when you are building your model, right? Then there's this whole set of data pre-processing. So this is also called cleansing, transforming data, making it ready so that it can go into a model, and you can get a output right away. Because often what happens is that there is so many back and forth between right data and the model throwing up a valid output, that if you do these first 3 steps right, or the second and third step right, you would ease the model output process a lot. It's just what we called shift left. I mean, you solve the problem early in the cycle, you save a lot of time of preventing rework and keeping on going back and forth because things have become complex, and now finding the actual problem becomes even more difficult, right? And then you do the model building, you go and iterate, you get more data, you keep playing around with the features till you get the best model that you can figure out before your deadline ends, which I told you is 3 days. And then you go and show your boss along with the visuals. So you're not just showing him an output from a linear programming solver which he can't understand because it's very complex. You're showing him a tool which is a chart which is telling him, okay, this is what the problem is, or this is what I predict the value will be 1 quarter or 1 year down the line, right? And then he knows whether you have to hire people, what kind of support he has to give you, what is the kind of spend you have to do on promotions and marketing and so on and so forth. And then finally you go about deploying the model into production, because once you have built the model, now the people who will be running the model are the sales people or people who will need this on an ongoing basis. So it gets pushed into what is called machine learning operations or data science operations. So the operations team maintains the model, right? So if you really look at age-wise where your skills will be helpful, clearly understanding business and really understanding the statistics and the technical tools and how to do coding, modeling, visualization, all these will become extremely important in the first few years of your job, because you have to be that specialist. You cannot rely on others. Going forward, again, you could be a person who is more familiar with the visualization, and you could have someone who's a modeling person as part of the same team. But I would say it wouldn't be more than 2 or 3 people at most who are working and getting stuff done, right? So again, you have very few choices when you're young in an organization, so you'll have to pretty much get your hands dirty. And therefore that's where Dr. Rakesh will cover the T part of the skills. That is what we hope to teach in this program as well. And then when you go to 4 to 8 years of experience, it's around managing people, and this is where you have to know all the deep skills, because otherwise people will take you for a ride with respect to how much time it takes to do a model, or how much time it takes to do a sub part of the task, right? So when you have done that yourself, you know exactly what it takes. So that's where it's not just about managing people and rating them, but it's also about ensuring that when you are presenting a project plan to your management, you know exactly the numbers are right and are achievable, right? And you're also able to guide the team. If there's something they're stuck with and they're using something which won't work, and that you can guide them and you can save a lot of time, right? So that kind of practitioner aspect of having done ML, AI models and algorithms, you can be a guide. When it comes to 8 to 12 years, and again, these are just numbers. I mean, it could change, and the cycle is keeping on reducing because these skills are getting very scarce, and people even with 4 years experience can become managers, or even senior project managers, given how fast they ramp up and show their value to an organization. And then if we really look at a senior person beyond project management, he has to be someone who's actually carving a story with a client. He needs to really go through what we call design thinking. So he's thinking from a client's shoes. He's the front person to the client, who's basically saying, okay, look, I will solve the problem with you. I will decide which problem has to be solved first, and I will get my team to work on that priority list. So I will get the low hanging fruits first. This will show the biggest impact to your organization. Then I will sort of get the projects where we have had a lot of experience, so that we know for sure we'll get those done. So whichever way you choose the impact and the prioritization, this is what is being decided by this person with the client CTO, or the person who's been designated to work with this organization, which is a consulting organization typically. And then when you go beyond 12 years, you actually start becoming someone who's a thought leader, right? So you then devise how you can bring in newer models and how your team practice can be cutting edge vis-a-vis your competing organization. So you become a practice leader, or the lead partner for a particular practice, right? So these are really the skill sets that would be core to data science practice. And so if I were to kind of really summarize, uh, whatever term you call decision sciences, data science, business analytics, they mean the same thing. They're different from business intelligence, as we had pointed out earlier. The data is the most important thing. It's not the model or the math or the algorithm. The quality of data is what gives the quality of output, and the faster we realize that, the better. Uh, the business context and domain is what drives value for a practitioner, and it also defines the right problem to solve. I mean, if you go all around in circles solving the wrong problem using the best mathematical tools, that's a complete waste of time, right? So I would leave it there, and what I would do is I'd hand over to Professor Dr. Rakesh, who's our dean, to take through uh, through the next few slides, and then I'll come back on. Yeah, Dr. Rakesh.
I hope I'm audible, Professor Soumya.
Yes. Yes.
All right. So once again, good afternoon, ladies and gentlemen. And like I said, apologies for joining the webinar a little late, as I had some power issues from where I'm, speaking to you. Just to introduce myself, I'm the Dean of Business School, and my name is Rakesh Madirata. I come and join the business school after about 28 years of working experience in the industry and about 3 years of experience in academics. I have worked with the companies like Hindustan Levers as their sales manager, and I have also worked with companies like Raymond, where I was the national sales head for a Park Avenue garment brand and the operational head for the Raymond stores. I have got about 13 to 14 years of experience with Vodafone, where I was in the sales and marketing department, and I was handling the national retail and the regional retail for them. So my expertise area is essentially from sales and customer experience, and that's my brief background. Soumya, I know you were waiting for me, so this is the right time if you would also like to say a few lines about yourself, so that I can then take them all through the slides that I have.
Yeah. So I am Shoma Chaudhary. I have 9 months as a professor. I came from industry around 23 years post my MBA. I worked primarily in management consulting briefly, and then investment banking. Worked for Merrill Lynch, Dressner Kleinwert, and KPMG. And then subsequently, I joined the auto industry because I was an auto and telecom guy. So I, joined my customer who was in the auto industry first as head of corporate finance, and then ran a business in supply chain for that organization, where I created a India parts outsourcing business to Europe. And then subsequently, I joined IBM, and I was with IBM for 10 years, first as head of M&A, and then subsequently as a large deal sales guy for outsourcing deals. And I covered, BFSI, banking, finance, mainly insurance, industrial and public sector. So that's really about me. And here I teach courses around supply chain analytics, data science, and digital business. Yeah, Dr. Rakesh,
Okay.
over to you.
Yeah, thank you so much. Thank you so much. So thank you, Professor Soumya, for just illustrating in detail about the program, which is the data science. As we are all aware, this program is now run by IFIM along with the partner Insofi. So it's got two parts to it. One is the management curriculum, and the second is the data science curriculum. I'll come to the curriculum bit in detail, but first, to some of us who may not be too familiar with IFIM, let me just give you a brief history and some important milestones about IFIM Business School. So we started in 1995 at a rented accommodation from the Shankari campus. So it's about, we just celebrated our 25 years of existence. So we are about 25, 26-year-old institute. In 8 years, we shifted to the premises that we are currently operating from. So this is in the Electronic City in Bangalore, and we share the same wall within in Infosys, and therefore this is situated in the IT hub of Bangalore City. The important thing that came to us first was the NBA accreditation, which is the Indian accreditation from National Board of Accreditations, and this gave us the confidence in terms of the kind of curriculum that we had for our management students. In 2009, the group of institutions grew, and we have now in 2009 established IFIM College, which was in affiliation with the Bangalore University. 2014 is something that again was a very important milestone for us, because we gained the South Asian Quality System accreditations. This was the first international accreditation that we got, and we became the members of the other accreditation committee programs. The institution further improved from, established in 2015 by, coming up with the IFM Law College. And 2017 was the year where we got our AACSB accreditation. So some of you would know that the AACSB accreditation is a gold standard accreditation where, we have currently approximately 14 odd schools which are currently accredited, and out of about 3,000 schools that exist in India. What this has brought is that now we are in a position to participate in global ranking. We can also tie up with global schools. Since we are a AACSB accredited schools, we can get our credits transferred to the other school, and therefore there is a whole lot of pathways, new pathways that get opened up for our students. And now in 2020, we launched our data science program. So this is a brief, kind of journey that we went through. And in 2020, which Dr. Soumya has just spoken to you, is our PGDM data science launch. So just go to the next slide so that I could, yeah. So now these are some of the important milestones, important pillars which I would like to speak, because this becomes very important for the student who takes admissions with us. So our mission is to groom holistic, socially responsible, and continuously employable professionals. And these are the three important foundations on which we work. Whether it is any activities that business school undertakes, these are the three things that we always take in mind. So whichever program our student comes in, we make sure that the student undergoes all these three experiences. So for instance, holistic is something to do with yourself. So we have a very elaborate course in personality enhancement program, which every student has to go through. So these are all credited courses where the students actually work on self and ensure that there is a self improvement plan, both from the health as well as the complete outlook of personality of a student. So this is the one of the pillars that I just spoke about. We have socially responsible. So we have something which is called our social immersion program, where almost all students are given a chance to work in remote locations of India and find out what the social challenges that the country faces. Because only once the student is exposed to all this will you then become a holistic manager and understands the complete 360-degree issues which one has to deal with. If you look at the same slide, I think we've got some of the very important offerings which we are very proud to present. The first is the grooming T-shaped professionals. So if I may ask you to just change the slides, it will be a better give you a better idea of T-shaped professionals. So this is something that our curriculum looks like. So there are two bars. One is the horizontal bar of a T, and the second is the vertical bar of the T. So if you see the horizontal bar, we have some courses which are called the conceptual courses. So whether there is a foundation course, core course, or practice course, this is to be completed in the PGDM management program, which is the management side of the program. So some of the core courses of management which are taught to every management students are compulsory here. We've got practice courses. Two of them I spoke to you just now. One was the personality enhancement program. The other was the your social immersion program. And we also have programs like IIP, which is your industry internship programs. So these form the practice kind of programs. So when you are taking, or a student who's taking admission into the PGDM data science program undergoes these basic core and foundation and practice courses at IFM, which are in line with any other management program which we offer. The other is a vertical bar, which is the contextual kind of courses, or which are vertical specialized courses, which are your majors, minors, or super specialization. And in this particular program, we are talking about data science as a super specialization sort of thing. It's a PGDM data science. So the electives in this particular program would be formed in the data science field, and this would be carried by our partner, which Professor Soumya is going to just speak about. So these are some of the important part of our curriculum. Now, before we actually devised this curriculum, we had to undergo a large amount of we did a very extensive survey with our industry partners, basically to find out what are the key skills that the Indian industry requires from our students. And therefore this program was launched only last year, and this is something which we say as curriculum 4.0, which is currently aligned to what the industry requires. So this is the snapshot of the T-shaped professionals that we would want to create. So Professor Soumya, could you come on the faculty slide, which I would want to also highlight in terms of the kind of composition that we have in terms of our faculty. Okay, so I mean, we have a faculty which is currently the mix of both industry as well as academia. Like I gave you my example, and like Professor Soumya also just introduced himself. We're from industry, and we've got some solid experience in various fields in the industry, and some of us have come from very senior positions. So if a student actually takes part in any of the program, gets a real perspective both from the industry angle as well as the academics perspective. So I think that way, I mean, if you can come onto our website and find out about our faculty and Google, you'll find them that there are some of those very respected faculties that we have. In terms of being technical, let me say that in terms of our curriculum, we've got 109 credits, and some of the credits will get divided in the management stream, and the others would be in the data science stream. So this is the entire curriculum that we have for you. Is there any other slide, Professor Soumya, in terms of introduction on the business school?
No, I think the next one goes into our partner slide, actually.
All right. So maybe we could come back again. So maybe you can continue with the partner slide.
Sure. Okay. Thank you, Dr. Rakesh. So, okay. So I think while the Dr. Rakesh talked about the industry experience as well as a lot of deep academic researchers we have as part of our faculty, and we also have a lot of young faculty, who come with experience in the modern data sciences or modern techniques angle. I think it's something where the business aspects would get very thoroughly covered, because this is what we've been doing for the last 25 years, and we're the sixth institution to get AACSB accreditation, as Dr. Rakesh had mentioned. The data science piece will actually get covered with our partner Insofi. Most of you would have heard of Insofi, which is actually now third ranked data science school in the country, but the fastest rising. I think they may have come up a notch or two. This was their 2018 ranking, actually. They have this set of 22 professors who are from the best US universities, and again we'll just come up to some of their profiles. So what is very important when you define the program that you want to join is, one, what is the practical exposure of the people who are teaching you? Two, what is the likeness to the real world problems? Because you should be industry ready. When you go onto a job, you don't need to basically get any more training. You just get pushed into a specific problem, and that's where you create your own strength and position for yourself in your new employer. The other is that the kind of real research and real world problem depth that people who are teaching you are. And that's where if you come to the practitioners at Insofi, all of them are industry practitioners. They really are solving these problems, whether directly for Insofi or in their own startups. They are full-time PhDs from the US, and they also have around 40 odd data science um, engineers who will actually aid the lab process. So all of us understand that you learn through a mix of theory and practice, and a lot of the practice should be, one, that the problems has to be real. The second is you should have
Professor
completed the
Soumya,
project.
Professor
Yeah.
Soumya, I'm sorry to I'm interrupting you. Could you extend the time, because the program will cut off in about 45 seconds?
Yeah, thank you.
Just extend the time. Yeah.
Yeah, done. So yeah, that was timely warning. So I think if you really look at this slide, so as I mentioned, 23 faculty, 45 full-time data scientists who actually help you with your capstone project. They help you get that project completed. See, the job is very dependent on the kind of projects you show, not necessarily just the certificate or those kind of things, right? So they want someone who they don't have to train, and so this is where I would say the strength of the program is, as Dr. Rakesh mentioned, T-shaped. So one set of very broad knowledge across business and technology, and very deep data science skills in one, the domain you choose to specialize in, which could be both the industry itself or a horizontal practice. So, for instance, if it is healthcare or digital supply chain or financial markets, these are the three areas that you could choose to specialize, and then you kind of become really a domain specialist in that. And in the problem you choose or the problem given to you, you will be using modern machine learning techniques. So not the support vector machines, decision trees, boosting and bagging kind of techniques. Those are all, I would say, conventional, traditional machine learning. You would be learning on deep learning techniques. You'd be learning about reinforcement learning, which is the latest, stuff on machine learning. And you would also be learning around blockchain and IoT. Incidentally, I also teach the blockchain course at IFIM. But the professor here in Sophie, Praful Chandra, is someone who runs a business. He understands blockchain extremely well. And then you have set of IoT and blockchain kind of where the physical meets I would say computer science and digital, where you can actually make something like a robot with your hands, right? So this is where something which is bringing in the techniques across areas is what is hoped to be taught in this program. So if you look at some of the people associated in Sophie, Dr. Dakshinamurthy, second from left, is the founder, and Dr. Sridhar Papu, fourth from right, fourth from left. And you have some of the other professors there who come from Johns Hopkins, Sunny Buffalo, and Illinois, and so on. In fact, Dr. Dakshinamurthy himself is from Carnegie Mellon, which, as you know, is the top 3 business schools in computer science. So, and then you look at some of the profile of the professors. As I said, Praful Chandra, he's the blockchain person. You have Rohit Lotlikar, who's structured data, Manoj Duse. So these are all people who are like, I know Rohit Lotlikar, he was a classmate of mine. He is a 48th ranker in IIT JEE. So, you realize, these are kind of people who are top-notch academics as well as practitioners. Rohit spent 20 years in IBM research. He's actually been someone who's productionized ML algorithms for services. Okay. So he's actually worked as someone who's led. He's the dean consulting, incidentally, in Insofi, and he will teach on structured data. You look at people like Dr. Anand Jayaraman. He's again another batchmate. He's someone who's worked in Wall Street for 18 years. Come back to India. He's now basically teaching financial markets. So the kind of depth that people will have here will really determine the kind of what comes out as you as professionals, right? Dr. Venkatesh Sunkar, who is the third from left, is the dean of Insofi. He's the person who you'll probably see the most if you enroll in our program. And he himself is someone who comes from Vodafone. I think with Dr. Rakesh, they were colleagues. He's someone who's an IoT specialist, and and so on and so forth. You have someone like Dr. Anand Narasimhamurthy, who's the supply chain logistics person, who probably covers part of that digital supply chain. So what I'm just trying to say is that when you look at both institutions, whether it's IFM with its 25-year history, disruptive curriculum, willing to take risk in courses so that students are the beneficiaries, and with all kinds of certifications, and you look at Insofi with alliances with Carnegie Mellon and Carleton and Case Western and various other universities, Rennes in France, and so does IFM also. So there are a lot of common universities where we are both partners, and these are people who can help guide some of the course curriculum. You can probably think of doing a super specialization with some collaboration with some of these partner universities. So there is a lot that can be had from a program of this. So to leave you with the last slide, and I don't want to take much time. I know there might be some time you want to ask some other questions which were not in the chat board or in the chat channel. So if you look at the kind of companies that both IFM and Insofi are able to cover, it's 500 plus recruiters, probably more. These are all product companies. These are not IT services, what was a conventional labor arbitrage model kind of place, right? These are people who are hiring you because you're a data scientist. You can solve a problem. You are reasonably familiar with coding. You know how to create a product out of data science. So whether it is Flipkart, Target, BCG, Boston Consulting Group, and so on, Amazon. So these are the kind of employers who are really hiring and who have hired in the past. Again, like I said, there are 500 sort of companies, hopefully more on the product side. And so placement is not a challenge. It is really, how you showcase what you have learned and what kind of projects you have completed. And you have the right infrastructure and support system with the data scientists and professors to be able to take you up that curve, right? So that's where I would leave it at. And if there's any specific queries you have for Dr. Rakesh or me, please, probably just put that on the chat and we'll probably answer online. Whatever has been sort of, I've tried to answer a few myself. The fees is around 9.9 lakhs. You can't imagine India fees and equivalent to a 30-40 lakh program that you would otherwise spend if you went to Australia or one of Canada or one of the developed countries for data science program. And which is and I just like to also I don't know if you can see my screen. So this is really where you will actually cover a lot on probabilities. You start with probability and statistics, which so anyone even without a math background, but should be not someone who's scared of math, right? Because you'll be living with statistics and math every day of your life. So someone who's neutral, who's wanting to learn, who's otherwise sharp but may not, for whatever reasons, have done math even at a class 12 level, can really apply. There is an entrance test where you have to get a 60% score, and then there's a GD and personal interview. So it's exactly similar to a business school RPGDM general program. Then you'll learn skills around R, Python. Spark is, of course, the Apache, Hadoop, streaming technologies. for big data analytics, and R and Python are the either language which you'll have to pick up for data science. Typically, R is more data science. Python is the universal language now of machine learning and data science. And similarly, you would cover, all these, regression techniques and, classifiers and so on, even into, regularization and ways to optimize your machine learning or deep learning models, which is, how do you make them converge faster, right? So all these kind of things you would be picking up. You would be kind of learning some of the older traditional machine learning decision trees, KNN, k-means, and so on and so forth. Like I said, bagging and boosting methods. Then you would be getting into core machine learning with linear programming and ANN, which is more the CNN, RNN, LSTM, RL, all these kind of things, right? These all become things you will kind of cover as you go on. Design thinking, very important, because you have to wear the domain and business context hat. And then, like I said, reinforcement learning, you'll learn all about Markov decision processes. Computer vision is what I said, CNN, image processing, uh, text mining, natural language processing. Again, here you could choose. I mean, you could choose to be in the CNN and the image processing side, or you could choose to be in the text mining and natural language understanding side. So these, typically people don't do both, but again, completely up to you. And then the technology aspects, right? How do you deploy the model? How do you get a pre-trained model so that you don't start training from scratch? How do you get data sets organized? How do you get data from outside? How do you cleanse it so that it's fit for your model? And how do you use container technologies, Kubernetes, Docker, all that, right? So these are all things that will be taught. And then the physical aspects, right? The IoT things. How do you integrate sensors? How do you get these to be feeding in the kind of feed frequency you want? How do you integrate this with blockchain? So these are the kind of rich things that this course will afford you. So like we said, there's a lot of stuff where you can either specialize in digital supply chain, in healthcare, or in financial markets. And that's really what I had to say. So hopefully that would have covered some of your questions. And the course is around 15 months. It's actually an accelerated course, but full time. You cannot do a job on the side because it's a very intense course. 16 hours of actual learning, 4 hours into 4 days, or could be longer, depending on really how how soon we can come out of this lockdown. And then the practice part, because like Dr. Rakesh mentioned, a lot of it is really dependent on the practice, right? So how much time do you spend in the lab to be able to ensure that your model is fit for industry use? It's not just something you have done to get a grade. So there is a huge difference between both these two approaches, and that's where we think is another orientation that all the professors have, that they want to make you industry ready. And biotechnology and those kind of aspects definitely can fit in, because there could be specific problems you choose for gene sequencing or other use of big data. It's really up to you to define. I'm sure there are some data scientists who are working in this domain, so don't presume that we will only constrain you to these three areas. If you have something very interesting in another area, absolutely. I mean, you'll also have the right specialists. If they're anywhere, they should be among those 43 data scientists and engineers who are part of the INSOFI pool of people aiding the progress. Should the data scientist be greater at insights than a product designer, or greater at program building? See, like we said, it's how deep you are in each of those three pillars. If you say, okay, I'm a computer science guy, I understand statistics well, I will stick to the model building and the technology aspects. Then someone else will come and complement you on the business and the domain side. But given that you are an MBA and you have done 54 credits of business courses, you will clearly be someone who can choose where you want to specialize. So it's really what we are trying to do is we are trying to create product managers who understand data science. So they're not just someone who are basically trying to get a team together, create project plans. They know about, really gate stage reviews and all these traditional product and project management kind of things, right? So we want you to know that, as well as, be someone who is deeper into the problem you're solving, because really the challenge comes from that. The challenge comes from the complexity of the problem. The challenge comes from being able to choose a better model, how to sidestep a NP complete problem or NP hard problem to get a real solution. I spent 3 weeks. I run a startup in supply chain. I spent 3 weeks on a bin packing problem, trying to solve a bin packing of a truck using all kinds of machine learning kind of algorithms. And then what we realized was that this was a something that the best case solution could be 4 times the optimum solution. So what were we trying to do? And optimization is trying to work at 1 to 1.5 times best case solution, and we are basically saying approximation algorithms is 4 times. So that's where really the understanding is that you have that real understanding that, look, this is something that cannot be done through optimization, and that is the wisdom that a course like this will give you, where you can even do a startup, for instance, where you need not work for other people. You can take a good idea, like someone who's working on biotechnology, and kind of go and create that next startup which is a pioneer in the space. It's a 15-month full-time course, and the last 2 or 3 months will be actually in a internship itself. So it's almost like, I would say, 12, 13 months where you're actually doing the core coursework, and then pretty much you can continue with that organization. If they like you, they can give you a pre-placement offer, whether it's someone like Target or BCG or Walmart, and then you sort of probably effectively spend 13 months, in a full-time program. So it's not really, I would say, 18 or 24 months. And that's what our focus is, to try and get you to a job as fast as we can. What publication, website, blog, conferences, books should we read so that we can increase our knowledge in data science domain? See, I think all these will be published by the professors as reading material in the course itself. Right now, if you're looking at preparation for the entrance exam, I think you should just brush up on your basic math, your arithmetic, and your statistics knowledge, right? Because these are like really 10th or 12th standard problems where you're just ensuring that you know some aspects of math and statistics. You're not someone who's like, completely, new to this and cannot pick up, because the course will be slightly fast paced. So, someone who's lagging behind will have a challenge. And that is from a theoretical concept. We are not talking of programming at all. Programming will be taught from, grounds up. So if you know nothing about R and Python, really doesn't matter. That's what you will learn in the course, and its application in. So you'll learn pandas, data frame. You'll learn, the core Python, the IPython, or Jupyter notebook, where depending on your familiarity with programming on a a green screen, or the traditional Jupyter kind of notebooks, you choose the environment you want to kind of work on, and then the visualization could be on Matplotlib, or Tableau, or some other external package as well, right? So don't bother about data science domain, those kind of things. I don't think even the personal interview and group discussion will have something which puts someone at an advantage, because he knew something about data science, right? So there are people who are quizzing me about NP complete stuff or SVM and all that. Really don't bother. I mean, all this will be taught. Like I showed you that program, everything will be taught. So we don't want to give any advantage to people just because they know 20% of data science versus someone who's at 0%. Which points regarding course should I consider to make up my mind? See, I think no one can help you make up your mind. I think what we have showcased in this should tell you that there is something which is an exciting career in data science, um, which exists. It will give you a salary which is equivalent to the best-in-class salary what you will earn as a management professional. So it's not that you will get a techie or a IT services pay scale. You'll get a uh, product manager kind of pay scale. If you have skill sets which are specialist area, like you're someone who is an expert in biotechnology and data science, right? I mean, people will just pick you up. Or if you are in digital supply chain, like I said, there are 5 or 6 companies who are trying to become big players in the space. Instacart, I'm sorry, Ninja Cart, Flipkart, Grofers, Amazon itself. They're trying to get into perishable items, right? Which is a challenge. How do you plan a supply chain around perishables? So if you are someone who's done work around this area, or you're someone who's worked around risk management in supply chain, or someone who's been able to solve risk. See, yesterday I was actually in a seminar for where a Maersk supply chain person was talking about his challenges in this COVID risk. And I can tell you, supply chain people, and I've been one of them myself, they are nowhere close to reality. I mean, this guy was talking 20,000 feet above the earth. Okay, they need help. If you are a consultant who can bring in deep supply chain consulting skill sets, and you can add a lot of value to enterprise, because people are just busy with their day-to-day tasks. They are really not conversant with a lot of these tools, because of the complexity of the tools, or because of the complexity of getting real-time data. They have chosen to use Excel and use some very basic techniques. I'm not saying the techniques throw up wrong results, or they are not giving you heuristic answers, but I mean, you are not there to you know um, assist in a heuristic rule of thumb decision. You are here to give pointed outputs, maybe a range of valuable predictions around the most important parameter that people are trying to, and that's what creates value for you. Because I don't know whether you have seen Hidden Figures. Okay, there's a lady who's Grace Kelly, works for NASA. She's the black. She's the person who gets pushed around the most, because everyone is a white in NASA. This is, I'm talking of 1950s, and everyone who's in the middle management is trying to showcase they are doing all the work, and actually it is this lady who's and then the top boss realizes she's the one who can work with her hands. She can literally think numbers, like Shakuntala Devi. I don't know whether you know, she's India's most prominent mathematician. And that's how suddenly she gets prominence. And the Joint Chiefs of Staff in NASA are now consulting only one person. Is this person called Grace Johnson or something? And now the latest center for NASA has been named after her. 3 years after she died. And so what I'm just telling you is, data science knowledge cannot be hidden. If you are good, everybody will know you're good. If you are someone who understands a domain well, automatically your salary will go up. And today is the age of specialists. It's not the age of generalists. I mean, when I graduated 25 years ago, people who went to Unilever and P&G and the Standard Chartered Bank were the highest paid guys, because they had an overall view as general managers. Today, that is no longer the case. You have to have T-shaped skills, but if you have deep skills and you are good in what you do, you automatically get singled out. And really, the stamp is only carries you that far if you are from an IIM or whatever. But if you are from a place where you have done real practical problems, you have had very good capstone projects, or your GitHub repository has great projects to boast of, every employer wants you. Period. Does artificial intelligence play any part? Yes. So artificial intelligence and machine learning is actually morphed. When we talk of deep learning, when a machine is recognizing a cat or a dog, which is what I talked about, CNN models, that is like akin to human intelligence, right? So you can call it machine learning, or you can call it artificial intelligence. Similarly, if cameras, which are kind of detecting terrorist threat, that is again image recognition, but if it triggers, the anti-terrorist cell saying, please take action right now, effectively it's done the same job as what some people who are monitoring the cameras, they could have been policemen or intelligence agents, would have done, and that the software is doing for you. So artificial intelligence and machine learning, very difficult to differentiate that. Artificial intelligence is pretty much part of the same package. Blockchain going to change the field majorly in the future? Yes, blockchain, the reason why it is going to disrupt industry is it's going to replace the entire process. So if you look at banking and blockchain, and let's take one specific part, like let's say settlements, right? Or you take back office, trading, or back office settlements, like for a treasury operations. Earlier, it was done through treasury back office, right? Today, that entire function of, let's say, the transactions, who's bought, sold, what quantity, what price, what time, all those records are being automatically captured in blockchain, and these are being sort of verified through consensus mechanism within, let's say, a permission blockchain. So let's say between a enterprise, between the person who's actually treasury back office, his manager, and the risk and compliance guy, right? Three of them, suppose they are three nodes, which does the same function, and they validate that, okay, this is actually what was true. What we will prove in blockchain is that it's very difficult to tamper with data, so you cannot manipulate data. Once it's put in the block, it is pretty much immutable. It cannot be changed. So blockchain is going to replace that entire process of settlements for, let's say, treasury fixed bonds trading, as an example. So it would start with this. If you look at supply chain, there is something called trade lens, which is not something which is just digitizing documents. It is something that is, let's say, connected from the shipper, the person who is the exporter, to the transporter, to the a node could also be the customs agency, which is clearing the container, the shipping line, which is shipping, to the destination port, external trade, all that stuff. All this is actually getting done through this platform called TradeLens. Go look up Maersk TradeLens, TradeLens. So these guys have replaced the entire process of export trade, and what used to take 21 days is taking 2 or 3 days, including transfer of money and all the steps that involve, let's say, customs person signing off, or shipping line generating a bill of lading that the container has come onto the ship, or dangerous goods declaration. These kind of documents which need to be prepared before consignment gets into the other port, all these are getting generated based on the previous steps automatically through the blockchain. There is no human intervention. All this is getting done by a set of computers called nodes, and this is the blockchain network. So what I'm just trying to tell you is why blockchain is going to be change the future is it's going to replace an entire process. So what do the people do whose job gets taken away? They become people who become validating nodes, or they just basically get into probably a design kind of role where they can bother about making things more efficient in terms of process flows, or they could get into something in a very different line. So they could actually get into data science themselves, or they get into blockchain themselves, and try and not beat this technology trend, but be part of it. So it's not a function of age, it's a function of your approach. I'm 50 years old, Dr. Rakesh is probably a few years older, but I think we are all trying to learn at our age, which is really a frame of mind. It's not really age kind of factor, right? You can be in your 20s and 30s and be dead, right? You can say that, okay, I just need to work 9 to 5. I don't need to learn anything new. I know everything that is needed to be learned, right? So who would you define as people who are more progressive? So is cybersecurity still going to be as important in future as it is today? Absolutely, because security risks, and if you've talked about IoT, right, it's the point where the highest security hazard is, what is called endpoint security. So people can actually, because things have become open source, and we need to make the IoT technology talk to the control system technology, talk to the computer technology, which is the back end. All these have to come onto a common platform, and so therefore it becomes very easy for someone who's a hacker to be able to also pretend to be an IoT sensor, and send in all kinds of malicious code into the system. So cybersecurity is going to be huge. It's absolutely huge, and it's not a computer job. Earlier people would think it's a IT guy, or infrastructure person who needs to know about all these things, or someone who's associated with cloud. No longer. I mean, cybersecurity is something that today, if you see, cloud is the most number of jobs. Okay, 100,000 jobs, or 400,000 jobs in India, right? So what is cloud jobs? These are the jobs that the earlier IT services guys used to have, but now everything is moved onto cloud from on-premise systems. So instead of maintaining a mainframe, you're maintaining helping people migrate their workload onto cloud, or you're helping sell a test cloud, or various kind of development clouds with different kind of technology, saying, look, whatever you need is there on our cloud, we just provision it for you. You are trying to talk to startups and say that, okay, if you adopt, we think that the whole ecosystem will work around that cloud. So that's what Amazon has been doing for years. Their main customer has been startups, incidentally, even though startups don't account for majority of their revenues. Similarly, if you look at a lot of enterprise cloud companies like IBM and Microsoft, everyone is moving to public cloud. Why? Because that is where the action is. 60-70% of the market size of, let's say, $8 billion in India, $4 to $5 billion will be public cloud. So if I believe that that is something that startups do, I don't make money, etc., etc., I will be left out of 5 billion out of an 8 billion market. So that's why cloud today is creating 100,000 to 400,000 jobs, which again will be more of the IT sales and I would say delivery kind of skills, right? So that's what the IT service people today are trying to move to, cloud kind of jobs. But if you are someone who really doesn't come from that industry, and you're not really interested in this, really hardcore tech kind of job, uh, you are more interested in solving a business problem, which I think most people are today, because you're closer to the CEO, right, or a CXO, or a decision maker. You yourself can be a CXO, given that you're following that line, right? You may not be a CTO or a CIO. You can be a CMO or CDO, Chief Marketing Officer, or Chief Digital Officer. So data science is giving you those more skills to be able to go into those kind of roles, because you're someone who's able to vision what technology will become. You are having the skill sets to know whether it is real or not, or it's just hype. If some people talk about blockchain and you're talking about blockchain, but you don't know anything about blockchain, then that's really something where you cannot play an effective role as a CDO, right? So you have to be coming from an aspect that you at least understand 50 or 60% of that domain. But your core should be something where you are the master. So cybersecurity, again, coming back to your question, is if you specialize in cybersecurity, even then you can actually be someone who can go into a CDO kind of role, because cybersecurity, end of the day, is something that people are extremely conscious of today. Any product, even if it's a startup product, the enterprise, if it's a B2B product, customer wants to know whether what kind of testing has been done, from a cybersecurity threat perspective, right? So, and then GDPR and all that, which is Europe data security standards, you have to be GDPR compliant. So there's a lot of need for cybersecurity skills, which goes beyond IT. Okay. Sorry, I keep probably speaking with a lot of other aspects, but just try and build some color so that you can really understand how important this field is going forward. It's not a techie job, believe me. It is something which is the next MBA job. Used to admire people who are the product manager in P&G or Hindustan Unilever. Today, the data science manager is that. Okay. Dr. Rakesh, if there's any point you had, sorry, if you wanted to
No,
make.
I think you've covered most of it. And if there are some other questions, probably they could, get in touch separately.
Yeah, I think we are
So
over time.
yeah,
So I think
so
what we'll all do is we'll kind of publish our email IDs, and whatever follow-up question you have, you can directly write to any of us about the course and curriculum and all those details. You can get in touch with Shonali, and they will give you all the details about the timing and program and everything. For anything related to the curriculum, or what exactly your doubts are into the relevance, or what kind of jobs you can take up, again, I'm sure Shonali can give you the first cut answers to that. But if there's anything that you want to know further, where you feel that you want to get in touch with us, go ahead, and I've also published my email ID. So what we'll do is, if there's no other questions, we will probably close the call. Shonali, what I'll do is just unmute you in case you have any other point you want to put up, and then we can quickly close the call. Sorry, I don't see Shonali on. Yeah, I do. Okay. For some reason, I can't unmute Shonali. So yeah, so I think just take a look once again. Yeah, so I think that's fine. Good. I'm glad, Farhan, you've probably got convinced with what this, and you can actually have as many questions as you have for us, and we'll be able to respond to you in a day's time. And I think don't be concerned with the whether the course is going to be very mathematical, or whether you have done maths in +2 or not. Even if you have done maths till class 10, that should be fine. This is open to graduates of any stream, not only science and engineering. But please be ready to work hard, because I think the interest and sincerity has to last throughout the course, and you should be able to group up with someone who complements your skill sets. Like I said, if you're a business domain person, who understands design thinking, who understands some of those aspects, but you also want to build your data science skills, which are deep. Initial part, you might want to team up with someone who comes from a computer science background, so that some of the nitty gritties around getting your projects done right makes it a smoother sail through for the program. The other thing I think is that there are plenty of people to support. I think that is the critical piece when you talk about the 25 data scientists, not the professors necessarily, because professors will cover the curriculum, and probably they'll cover some of the higher level questions and guide you to the right resources. But who's the person sitting with you to ensure your code runs, or it's something that is complex enough that it is attractive to industry. It's not something, like I said, just to get a grade, or something that just works. That is where the support mechanism and the infrastructure should be something you should be very careful about in the program you enroll. And I have, in the last few days, attended a lot of calls by these e-learning companies, and I can tell you there is a lot to be desired. I don't want to badmouth people, but I'm just saying that, be very careful when you enroll for these programs, because you should know the credentials of the people teaching you, and the people supporting you in the practical aspects of the program. Because finally, what you're learning is how to create that problem that is solved with a real code, or documentation and a working model, right? Because you want something to work. So it's not something that you're getting by just convincing your boss you add value, but you actually add no value, right? So that's the most dangerous role, by the way. So so try and get some deep skills, and try and get deep into the T-shaped skills. As we said, these are the relevant skills of today. So good luck, and try and take the test. Try and prepare to a to an extent, but don't go overboard. And go through the websites of both the of IFIM and Insofi. And once you're convinced that these are the right people who should be teaching you, then go ahead and pay the exam fees and so on. As a BCA student, I would like to know which course would be better to be pursued: MCA, MBA, and data science. Look, there's no real. I think the MCA is redundant today. Frankly, I don't know how many IT people are on the call, but MCA is, I think, not something that is valued. There's a huge difference between MCA and a BS in computer science, or a BE in computer science. MBA and data science depends on you. You want to be a brand manager, you want to be in marketing, or hardcore finance. Maybe MBA general is better. Data science is for those people who are passionate about data science. So all the problems we talked about today, if you think that that's the kind of problem you want to solve for the next 10 years of your life, forget 30 years, right? 10 years of your life. Maybe after 10 years, you do your own startup, right? So, after 23 years, I'm doing my own startup, right? And with the IIT and IIM qualification, I mean, I don't think getting a job is, the concern. It is what you think is the relevant thing to do at your stage of life, or what you think you are capable of doing, right? So try and basically see what interests you, not what looks good to your parents or your uncles, or what have you. If this is something that you're interested to do next 10 years of your life, you are proud to be a data scientist and not MBA and some other kind of company, go ahead and take the test, right? So good luck to you guys, and look forward to seeing some of you in the program. Thank you. I'll just close the call.